Hello, in this episode we're going to look at how to integrate our dynamic MMO style inventory with our Unreal Engine client. So what we've done in the previous episode, we've created some of the changes inside our backend server. So this is to support inventory over WebSockets. Therefore we can fetch the inventory through WebSockets whenever there's any changes to, items being dropped on the map or us picking them up. Those changes are also highlighted through WebSockets. So what we're going to do here is start integrating that with our Unreal Engine client, receive those updates, and then show them in the world, right? So that's what we're going to look at here, and perhaps we'll get started with a quick demo. Okay, so with the server up and running, what we're going to do is we're going to sign into two of the characters. So I've signed into character 2 there, and I'll sign into character 3 here. And what I'll do is I'll basically try and make it so that you can see both of them simultaneously. So each character has one instance of the item each. So basically I've created an item and I've given both of these character this item. So what I can do is I can drop this item. You can see it's appeared on this client as well as that one pretty much simultaneously, right? Well, it should be simultaneous. And both of these characters are now able to interact with it. So you can see this one also has this item. I can click P, which is bound to picking up a nearby item. And now this character has two of these items. So you can see now I'm able to interact with the inventory now using this new system. So again, I'll be able to pick up that nearby item with the button P. There's some other interesting aspects as well. So I've dropped that item again. You can see it's over there. And if I walk far enough, you'll be able to see that the item will disappear. So my threshold is, I don't remember what the units are, but I'll enlarge it later. But this is just to prove the fact that if we walk outside the threshold distance, the item will disappear. And now I've come into the threshold and now it's appeared again. So the item still exists, right? And I'll be able to pick it up again using the button P. And you can see it's gone now. Okay, so that's what we're going to be looking at implementing inside Unreal Engine, which is basically integrating with the WebSockets that I've discussed in the previous episode. All right, so let's get started. Okay, so the majority of the blueprints that we've created will be inside this new inventory component. And this is what we're going to be attaching to our player, right? So inside of the player character blueprint, so this is our player blueprint. We used to have this player socket integration, and now we've added the inventory component to deal with all inventory related things. So, when you open your inventory, you can see all of the items there. When you drop an item, when you pick it up, it will deal with all of those, as well as in future we'll deal with equipping items and things like that. So they'll basically sit inside this component. Now bear in mind that we'll still handle all the communication via the player socket integration. So part of our constructor here will want to link those two components up because they'll need to be aware of each other to make use of existing functionality. Okay, so that's what we're going to be looking at doing here. So we'll begin with the inventory component first. So part of the constructor, what we'll want to do is set a couple of parameters up that we'll be using, to help us with other functions. So for example, at the beginning, we want to set the count character. So this includes information like your character name, things like that. We'll have a reference to our player character blueprint. The reason for that is I don't think I've used it just yet, but soon I'll need to be modifying the appearance information. So whenever you equip an item, you'll need to change the character mesh. So that's why I will need the reference to the player character blueprint in order to change the material and the meshes that are applied to that blueprint. But mainly I also need the player socket integration. So the actual messages will still be sent via the player socket integration. We want to reuse those blueprints. The next thing that I do is map out the input system. So basically we've got two new inputs, one to open the inventory, one to pick up nearby items. So I'll show you those shortly. So we added a new mapping for those. We spawn the character capture blueprint. So inside the inventory, we have a character which represents our character. So that's what this thing is. There's a separate post covering that. and then we create the inventory using the inventory component. So this is the one which spawns the widgets, adds it to the viewport, makes it hidden, and yeah, it basically just initializes our inventory for us. Now, there's different widgets with different functionalities, so this could make things a little bit more difficult when trying to reference different components, but I'll again highlight those challenges shortly. Okay, so that's the constructor. I also had the fetch inventory inside this inventory component before. I've disconnected it because it can sometimes have race conditions. So if you call this before the WebSocket is initialized, this request will fail. Now you could add a retry to it, which would be sensible, but it's a bit more logic. So what I've instead done is I've asked to fetch the inventory after I know that the WebSocket has been initialized and started. Okay, so we'll get started with the player character blueprint, and specifically we want to have a look at what happens when we begin play. So when we construct our player character, one of the things that we do is configure the socket integration, and we've looked at this in the past, which is not relevant to the inventory, but what I want to highlight is that here we configure the socket connection, so this is where we basically instantiate it, and what we're going to do after is add the components to the game instance, which is just making it easier for us to access in the future. And then we fetch the inventory from the server. So you can see now I've placed the fetch inventory from server after I've configured the WebSocket. And let's have a look at what this does. So this is using the inventory component. We make a request. So this is a socket message structure to fetch the inventory. So you can see the update type here is fetch inventory, and we just need to specify the name. Now, I need to make a couple of changes in the backend because you can see it's duplicated here. This was really to make it a bit easier in the backend to process it, because I'm actually passing the generic inventory data for the processing, and this player name is kind of mocking the authentication, which is not currently done. I'll look to fix this later, but basically, in order to fetch the inventory, we just need to specify the player's name and just a command to say, fetch me the inventory. So I've also refactored this send message, which is still inside the inventory component. But what it does is simply link the socket integration and says to the socket integration, send this message with the following structure. Now, I just didn't want to basically link this socket integration every time I wanted to send the message, which is why I did it like this. And inside here, this was a bit of a game changer. So I've now started using this struct to JSON component. So this is inside the Epic store. I think it was about £4 or £5, and really it saved me a lot of time because now I don't need to write custom serializers and deserializers. So I just basically take my structure, it gives me the JSON, I take my WebSocket client and I say send this message. And it doesn't even wait for a response because the responses are handled completely separately in an async manner. So that's sort of the end of the story here. Okay, so what we can look at next is how we get the response, which is part of configure socket. So what we do is part of the WebSocket client, we have this bind event on message received. So anytime we receive a message, this custom event gets fired up. And you can see that our message is a string. So what we're going to do is convert it to a structure. So this structure is a generic structure which basically represents any combination of data from our server. So you can see it can contain like many different things. In this case, we care about just the message type. And I mentioned this before, but this acts as sort of a post office where based on the message type, we know where to route this response. So in this case, it's update inventory. So we know we want to call this function. So this is still inside the player socket integration component. And we've referenced the inventory component earlier. So we've linked them part of the constructor flow. So now we can use this component and say, process the inventory response, and this is the socket response that we got. So inside here, so this is what takes us back to the inventory component. We get the socket response. So inside there, we now want to look at the inventory data, and the inventory data contains the actual inventory, which is a combination of your character items. So character items is a structure which basically includes the location in the inventory. It's a 2D location, like XY coordinate, as well as the character item itself. So mainly the character item ID, or just the item ID, which we use to know which mesh to use or which image to draw inside your inventories. So with that, we take our styled inventory contents, which is a widget inside our inventory, and we tell it to process it. So I'm not going to go into too much detail of this blueprint, but it is available inside the blog post, so check that out if you'd like to know how it works. But basically, we take our inventory. Inside there, you can see we've got these character items, and for each one, we want to process and draw them inside our inventory. So again, to just show what this widget looks like, it's this one over here. And inside this inventory contents, we're going to be drawing these inventory slots. So each of the character items will pop up inside the inventory as these slots. Perhaps I'll just quickly show that in action. So when we log in, if I click I, this is the inventory widget. So this is the widget which we tell, draw our items. And for each item that's part of our inventory, we create this new slot. Okay, so that's how we populate those items inside here. Okay, so now that we've seen how we populate the items inside the inventory, or rather the data flow of those items, what we can have a look at next is how to drop an item. So basically, when we populate the items inside our inventory, we create these inventory slots. And when you right-click this inventory slot, we create this little menu over here. So this allows us to click either equip item or drop item. So we're going to look at the drop item functionality. So essentially, when you create those item slots, you provide it the reference of the character item, and the character item includes things like item ID, right, and the location of that item. And what I do as well is I grab my game instance in order to extract my inventory component, and I've done that because these widgets are sort of nested, and I didn't want to keep having to pass the inventory component through those nested components, right? Because basically I have the movable inventory window, then I've got the inventory contents, then I've got the slot for the item, and then from the slot I generate this menu. So I didn't want to have to push the inventory component all through those other components. So instead I've added it into the game instance, so I'm able to simply extract the inventory component through the game instance here. Okay, so I've created this function inside the inventory component to drop an item, and then I can remove this widget from parent. So because, once you clicked it, you don't need this widget to be visible anymore. So let's have a look at what happens when we click drop item. So we basically have a function inside the inventory component. So you can see I grab the player reference, and I do that in order to get the XYZ coordinates of the player. So this is where I will actually drop the item. And I also have the map where the player is currently at. So I then want to construct myself the message which I need to send to the server. So the message requires the inventory location of the item that I wish to drop. So this is the XY coordinate from the inventory. And I'm thinking of changing this to represent as the item instance ID. So I'll change this perhaps later in the future. But something unique to identify the item is what we need here. And I need the location to drop the item. And I also just need the character name, which player is this referring to, right? So that's what I need in order to create the drop item request. And then I put it inside the socket message structure with the update type of drop item, and I again send that message over. So again, this is inside the inventory component. I'm referencing the socket integration, and I just ask it to send the message. So it's going through the same flow as before. So the other neat thing here is that basically when I dropped this item, you saw that I didn't actually request to update the inventory and stuff like that as well. So those will happen dynamically. So basically the server, after processing the drop item request, will give me two responses back. One, to update my inventory, and the second is to draw a new dropped item on the map to the players that care about it. So again, that'll happen through the configure socket. So one of them will update my inventory, which we already looked at, and the next one is I add items to map. right? So like I say, when you click drop items, it will remove it from your inventory. It will send you your updated inventory, and then it will send me a message to draw an item on the map. Okay, so again, it's calling this function inside the player socket integration. It's using the reference to the inventory component, and it's basically asking it to process this function. Okay, so the socket message response, it has another field here for dropped items. This is a map, and this map contains keys referring to the dropped item IDs and this dropped item structure. Again, I'm not going to go into too much detail on how this works. The details are inside the blog post if you like. The main thing is that for each one of those dropped items, we want to spawn an item on the map. So you can see that basically we grab the item instance structure, so it contains your item ID here, and we want to resolve the item skeletal mesh. I'll quickly show this one because I think it's a neat little function. It's very simple, it just has a map of IDs to skeletal meshes. So this is the one that we're actually using. I've got an item with ID 17,000, and it refers to this staff, mage staff, right? So that's what we're going to be spawning inside our inside the map. So basically we spawn this item actor on the map, and we tell it to use this mesh, and we resolve the mesh based on the item ID. And we then added it to a variable of nearby dropped items. So whenever we move far away from this item as well, the server will tell us to remove one of these dropped items. So we know this is like the variable that we're going to use to handle those requests, right? So one additional thing that I've added to the dropped item structure is the reference of the actor itself. So you can see me setting members in dropped item structure. So I provided the actor reference that I've spawned so that I can also destroy it later when it's no longer visible to this user. And that's actually what we're going to look at next as well. So the next thing we'll look at is how to pick up an item and remove these items from the map. So in order to pick up items, what we've done is we've created some new input actions. Okay, so I'll go into here. So I've created a new folder for input actions. There's only two new actions that we need to look at. One is open inventory, the other one is pick up items. So these are both just your simple digital booleans. So both of them have the same characteristics there. And you can see that the inventory actions here, pick up item mapped to letter P, and open inventory mapped to a letter I. So whenever I click P, I'm going to pick up an item. Whenever I click I, I'm going to open up the inventory. So that's what it refers to. So we already had a look inside the event begin play where we map those out. So you can see add mapping context. So you can see I've added the inventory actions over here. So what that means is I'm able to now use these open inventory actions. So you can see here, I added a flip-flop. When it's clicked once, it's going to set my inventory widget to become visible. When I click it again, it will make it invisible, and so on. Okay, and when I click the letter P, I'm going to try and pick up one of the nearby items. Okay, so the way that this works is basically I need an ID for the item I'm trying to pick up. And the way I do that is look through my nearby dropped items. So if I have an entry inside this map, I'm going to just provide the dropped item ID, which is one of the keys. And I'm only going to do it if this map is not empty, right? And yeah, so if this item is found, I have myself the item instance ID here. So what I want to do is create a request to pick up an item. So in order to do that, I just need to specify the character name and the item instance ID. So we had a look at these requests in the previous video. So now we're just implementing them part of Unreal Engine Flow. So you can see this is the request that we're making. We put it into this structure, specifying the update type to be picking up an item. And then we again send a message to the WebSocket. So socket integration, send a message, and it's going to go ahead and process that. So once the server processes this request, again, it will give us two responses, one of them for our updated inventory and the other one for removing the item from a map to the players that are nearby to this item, right? So the players that are interested in this update. So that's the last response over here. So this is remove items from map. And we can have a look at this functionality here as well. So again, we're referencing the inventory component and we're telling it to remove the items. And here, I've just simply provided an array of item instance IDs. So we're going to simply loop through each one. We have the map here, nearby dropped items. So we look for this item. And if it found it, first of all, we're going to destroy the actor reference so that it's destroyed from our map, destroyed from our world, and then we'll remove that entry from the nearby dropped items so we don't have to process it again. So this function is actually quite simple, and that's what really completes it. So you can see everything is dynamic. We're not polling the server for, you know, give me our inventory state every like 0.5 seconds or whatever. We simply just wait for a response. If there's a change, the server will automatically evaluate it and push the changes to us. So yeah, that's it for this part. And I guess we can just finish off with a quick demo again. So I'll just basically talk about what is it doing when it's doing it. So if I log in, I'm going to open my inventory. So basically when my character spawned, part of the constructor, I go ahead and fetch my inventory. My inventory itself is invisible by default, but when I click the letter I, it makes it visible again. So this is one of the input actions making that visible. When the inventory is populated, it iterates through all of the character items and it creates a slot for each one. The slot based on your item ID will draw an item, right? So an image representing that item. Now, when I right click this slot, it creates this menu and I'm able to click this drop item. So what this does is it asks the game instance for the inventory widget or inventory component, and it sends the request to drop the item using that inventory component. When I also drop it, I get two responses from the server, one to update my inventory, which it just processes dynamically, and the second one to draw an item on the map. So I now have an array, a map of drop items as referenced inside the inventory component. And it iterates through each one and draws the dropped item on the map. Now, when I click P, it's going to go through that variable again and basically take the first one that it finds, and it creates a structure to pick up that item. It sends that to the server. It again generates two responses, one of them to update my inventory, the other one to remove that dropped item from the map. And yeah, that's basically it. So yeah, thanks for watching and see you next time. Thanks. Bye.